Okay, welcome to your next video in AP Statistics. This is 2.2 Empirical Rule, Standard Normal Curve. We're going to be talking about normal distributions today. I know you've seen them before in other classes, but what we're going to do is go a little bit further with our understanding of them and use them today. Here's today's AP Statistics standard. And our essential question is, what is the standard normal curve? Okay, so more than just knowing what a normal distribution is, what is a standard normal? How can we use it? What is it used for? So we're going to start out talking about the empirical rule. And the empirical rule is sometimes called a different name. But the empirical rule tells us about areas that are underneath our normal distribution. We ended our discussion yesterday, in yesterday's video, discussing density curves. And the normal distribution is a very important and particular density curve. And it's used for a lot of situations. Now, not all situations are normal. And I don't mean normal as in weird versus normal. I mean normal as in terms of the distribution type. So here, we're talking about the empirical rule. So within certain areas underneath the normal curve, we can memorize and know the amount of area that is between any two standard deviation points. Here's what I mean. If you've got your mean at the center, within one standard deviation to the right or left of that mean, you're going to find 68% of the data. If you go out 2 standard deviations from the mean to the right and the left, you will find 95% of the data. If you go out 3 standard deviations from the mean, so to the right and to the left, 3 standard deviations, you will find 99.7% of your data. That's a pretty significant portion of your data. That means 0.3% is left of the calculation. So the vast majority of your data is going to be found within 3 standard deviations of the mean. And a significant majority of that is only between 2 standard deviations of the mean. So graphically, let's take a look at it. This is what that rule means. Here, our mean is at the center of the standard deviation and the normal curve, excuse me. The standard deviations have been added to the right and subtracted to the left. This is going to drive me crazy. So I'm going to make sure that you realize that this is supposed to be subtraction there. That's not addition. The mean at the center, at the peak, we add standard deviations to the right and subtract standard deviations to the left. Within one standard deviation, this piece to the right of the mean and one standard deviation is worth 34%. It's where 34% of your data is. And a mirror image, because this distribution is symmetric, 34% is between the mean and one standard deviation to the left. You go out another standard deviation, you add another 13.5% on each side. And a third and final standard deviation out, you'll get 2.35%. That leaves 0.15% in the tails here, beyond 3 standard deviations of your mean. So this is where the 68, 95, 99.7 rule comes in, or the empirical rule. Some things to keep in mind about the normal distribution. What makes it normal? Why is it different from the other density curves? Well, normal distribution is a bell-shaped curve with mean, median, and mode all located at the same point, which is the peak. It's symmetrical about the mean, which you could see that it was symmetrical. The area under the curve equals 1, just like with density curves, like we discussed yesterday, was density curve area underneath the curve is 1. The curve never crosses over the horizontal axis, so those tail ends go forever in both directions. However, the area between the curve and the horizontal axis gets smaller and smaller and smaller. So less and less and less chance you're going to get to data there. So it goes on forever in both directions. The area just gets smaller and smaller. Now let's talk about what's called the standard normal curve. It's not exactly the normal distribution per se, it's a map of the normal distribution. And this is how we find areas that don't lie directly on those nice standard deviation lines of the empirical rule. So say a value falls somewhere in between one of those lines. How do we find out the area? Well, this is how we do it. We map everything onto what's called the standard normal curve. So a normal distribution, mean mu, and standard deviation sigma. The mean of this standard normal is 0, and the standard deviation is 1. So if this is our normal distribution, we're going to map it onto the normal distribution with a mean 0 and standard deviation 1. So this is the curve. All right, so here are our values. 0 is at the mean, the middle. We have 1 standard deviation to the right, 2 standard deviations to the right, and 3 standard deviations to the right. Those are all positive. Whereas if we're going to the left, that makes our standard deviation value negative because we're subtracting from the mean in order to go in that direction. So when we calculate a z-score from yesterday, we were finding how many standard deviations to the right and the left of the mean something is. So here we're going to calculate a z-score the exact way that I showed you yesterday. You take your x value that you're looking for, you subtract from it the mean, and you divide that by the standard deviation, and that gives you your z-score. Here's what we do beyond that. When we draw our curve, we mark the mean, and we're going to mark that x value on the horizontal axis, wherever that is. And we calculate the z-score of that value. We're going to shade whichever direction that we are looking for. So if I wanted 0.5, something that gave me a 0.5 z-score here, I'm going to shade, if I wanted to know what is less than, what's the probability that something is less than, or the area percentage that is less than that point, then I would shade to the left because this is the area that would be less than that point. And I'd look up that z-value into the z-score table. This is the standard normal table, and underneath each z-score that you can look up, you will find the area that is to the left of that point. In some circumstances, we don't want the area that's to the left. We're going to have to perform some subtraction. So those are our steps. Here's things that we need to remember while we're doing this. The total area under the curve is 1 or 100%, just like the density curves that we discussed yesterday. And the table only gives the area to the left of any given z-score. So if you want the area to the right or the area between two values, you're going to have to do some calculation. Here are the cases that you could possibly want. Case 1, I want the area to the left. I find that the z-score for my x value is 0.81, which puts me right here. And I want the area to the left, so I shade to the left. I look up the table entry for a z-score of 0.81, and I find that it tells me a probability of 0.7910, or 79.10%. That tells me this area is 79.10%, or a probability of 0.7910. I'm done. This is the probability area that I wanted. Now here's another option that I could be looking for. I could be looking for the area that's to the right of a z-score value. So I calculate my z-score for some x value, and I get that my z-score, for example, could be negative 1.78. But I want the area that's to the right. So when I look this up into the table, the standard normal table, it gives me a probability of 0.0375 or 3.75% of the area. But this is the area that's to the left. I don't want the area that's to the left. Well, remember the area under the entire curve is 1. So if I take 1, which is the entire area, and subtract from it the area that I don't want, which is the area that's to the left, I get the area that I want. So I take 1, subtract 0.0375%, and I get 0.9625%. So that's how I find the area that's to the right. I take the whole thing of 1, subtract the piece that you don't want, which is the value you got from the table, get the piece that you do want, which is 96.25% or 0.9625. There's another case, the case in which I want the area between two values. So what I do is I have to find two z-scores. Let's say I want the z-score here and the z-score here. This is a z-score of negative 1.25, which gives me an area of 0.1056. So this is a z-score for 0.81 and gives me an area of 0.7910. But I want the portion that's between those two values. I see that the area to the left of a z-score of 0.81 is the entire piece. And I don't want the piece that is here. So I take the large piece and subtract from it the piece that I don't want, and I end up the value between those two z-scores. So I take the z-score for the larger value, look it up in the table, and the z-score for the smaller value and look it up in the table, and I subtract the table values from one another. I do not subtract z-scores. That would be bad form. You should never end up with a negative area. And in a circumstance where you have two values that you are looking for an area between, you will need to look up two values in the z-score table. Do not subtract your z-scores. It will not give you the correct answer. Okay? So let's take a look at some. Let's find the area underneath the standard normal curve for the given values of z. Okay? You have a z-score table in your plastic sheet that I gave you, which is your AP Statistics formula sheet. You have both a negative and a positive side. They're side by side. But when you look up for a negative z-score, make sure you're looking on the negative table. You're going to look up the negative 1.3 row on the left side and find the 0.02 column over the top and find where those two values meet up, and that's going to tell you the area to the left of a z-score of negative 1.32. I think an area of negative 1.32, that's probably going to be around here somewhere. And if I want the area that's to the left of that, then I shade to the left. That's the area that I want. But when I look it up in the table, that z-score of negative 1.32, I get 0.0934. So this area is 9.34% or 0.0934. Let's look to the left of a z-score of 0.74. 0.74, that's positive, so that's between your mean and one standard deviation. So almost one standard deviation. How about one right there? Now I want to the left of that, so this is the area that I want. Shade that in. And I look up that z-score in my z-score table, and I get 0.7704. So this area is 77.04% of the area underneath the curve, or 0.7704 out of the total of 1. What about the area to the right of a z-score? Remember, first we start out the same, negative 1.85, okay, about right here will be that z-score. And I want the area, though, that's to the right. So here, remember my z-score table, my standard normal table value is not going to be giving me something that is the area that's to the right. It will only give me the area to the left. So in that circumstance, I not only look up my z-score of for my probability for a z-score of negative 1.85, I also then take that value and subtract it from 1. So the value from the table was 0.0322. I'm going to subtract that from 1 and get 0.9678. So that is the area to the right, or 96.78%. Another case 2 situation, I have a z-score of 2.11. So again, positive 1, positive 2.11. How about right there? And then I want the area to the right. So this little piece right there. I look it up in the table and find that it's 0.9826. But remember, the area to the right, I have to subtract it from 1. And I get 0.0174. You should be able to look at this little area piece and realize that that does not correspond with 98.26% of the area. Okay, how about between two z-scores? Okay, remember, we're going to have to look up both of these z-scores in the table, because what we want to find is between a z-score of negative 0.59 and positive 1.67. So the area between those 2 points first, I'm going to look up both of those values in the table. The z-score for positive 1.67 is going to be greater, the value that you get out of your table for the z-score of positive 1.67 is going to be greater than the value you get out of your table for your negative 0.59 z-score. You're going to take this larger one and subtract from it this area of this tail piece that you don't want in your area, and you'll get the area from the right piece was 0.9525 and subtract 0.2776 and you'll get 0.6749. Let's try that again. Let's look at 2 more areas. Okay, these are both between positive z-scores. So mean is at the center, 1.48 standard deviations to the right, and positive 2.96. So, excuse me, that last line was not very good, was it? Okay. 1.48. There we go. And then 2.96. So right up here. So the area between those two. Well, I'm going to take the area that's to the left of this point and subtract from it the area that's to the left of this point. And I'm going to get 0.9985 minus 0.9306 is an area of 0.0679 or 6.79%. Okay, and this is going to conclude today's practice with z-scores, the standard normal, and your empirical rule. And when we see you back in class, we'll do a little bit of practice with this.